My name is Sailin Zhong. I'm a PhD student from the University of Fribourg in Switzerland. Here, I'd like to present to you my topic for the CHI 2022 Doctoral Consortium, Augmenting the Human Perception of Comfort through Interactive AI. This work lies at the intersection of SIGCHI and architectural field. In the architecture field, efforts have been made towards making the guidelines for IQ and improving building efficiency. This is a top-down approach where the building is in the hand of professional facility managers and the machine itself, and may result in interaction gaps between the occupants and the environment. A new notion in SIGCHI, namely human building interaction, consists of providing interactive opportunities for people to shape the physical, spatial, and social impacts of their built environment are introduced. And my work will situate in this subfield with prediction and prevention approach to promote habitual changes. The whole PhD is composed of 4 case studies to cover social and personal contexts. For the IEQ dimensions, the studies attempt to tackle ones that human sensor has difficulty with using artificial sensing, and the ones that human sensor can partially reflect on using augmented human sensing. There are 4 research questions that this thesis will address: the subjective and objective sensory relationships, the prediction methods, the interaction design, and the social context. Moving on to the first case study for artificial sensing, we developed the environmental sensing device, HELO, and conducted a control study on 3 interfaces. We found that the visualization of CO2 forecasts could support participants in taking preventative actions and shed light on necessary future improvements on the interaction between various IEQ dimensions. Case study 2 had been carried out by studying 1,007 meeting sessions. 7 patterns of CO2 evolution during the meetings were elicited. Interactive solutions that would minimize the cost of notification and interruption of the meeting were designed, informed by 2 online studies. For augmented human sensing, we started with understanding user acoustic experience in hybrid meetings. The eye tracking data revealed that binaural audio can improve speaker identification, especially when qualitative attendees wear masks. The next leg of my PhD agenda is to augment visual comfort in personal and social contexts. We conducted a survey on home office conditions in both individual work and conferencing contexts. I found similar conclusions at True and Hall's boundary of work, where 2 distinct user groups can be found. Among them, I plan to develop a webcam-based system for rigid mindset users and a variable system of fuzzy mindset users to better manage their visual comfort. In summary, this thesis will contribute to HCI in field data, predictive algorithms, design instances, and design implications.